All right, ladies and gentlemen, back to proofs. All these proofs are going to end in HL. Okay, then we'll get to CPCTC proofs. So here you're really going to apply what you have learned in that previous those previous videos. Again, each one of these proofs is selected for a certain reason. In this one, it's because we're going to be using these equal statements, these equations right here, and we're going to prove that they're congruent. So this one's all about the definition of congruence. This guy down here is going to be about that perpendicular again. So again, I'm highlighting these proofs because this is stuff that you need to be able to pull off in proofs in your homework, your quizzes, and your tests. So go ahead and try these proofs. Remember, you always begin with the given. Make sure that you mark up your pictures. These should end in HL. So give it a shot and go. Alright, so up here, triangle ABC and triangle DEF are right triangles. So that's an important statement because that means that we can definitely use HL because we need right triangles. We also know that AB equals DE, and we know that CB equals FE. So all that is given. Okay? Well, in order to get HL, I have to show that the hypotenuse and the leg are congruent. Well, we almost show that. If these things are equal, AB and DE are equal. If you're equal, that means that you have the same measure. And if you have the same measure, that means that you have to be congruent. So we know that these two pieces have to be congruent because they're equal in measure. And the reason we know that is because that's what it means to be congruent. Okay? So the definition of congruence. Again, your guys' homework and your quiz or your test, it might say definition of congruent segments. Or if you had angle measures up here that you said that the angles are congruent, it might say definition of congruent angles. It's all the same thing. I don't worry about saying segment or angle here. It's just because they're congruent. That's what it means to be congruent. You are the same measure. So the same thing can be said about the next piece. And if you notice, that was a leg that was congruent. If I look at CB, CB, it's right across from my right angle. And FE is right across from my right angle. So this must be proving that the hypotenuse is congruent because CB and FE are the hypotenuse. And they're equal. They're equal. If they're equal, that means they are congruent. Okay, that's what's great about equal statements. If you're equal, then you're congruent, and vice versa. If I needed something to be equal, I could go from congruence back to equals because the definition of congruence. I'm putting both of these in the same step because to go from equals to congruence, that's just your definition. And if you look up here, I've got a right triangle. Check. I've got my leg. I've got my hypotenuse. So yes, I can use HL to prove that these triangles are congruent. Triangle ABC congruent to triangle DEF. Because of HL. Alright, looking at this guy. A little bit more involved. 5 steps for us. Okay? So we know that we have perpendicular, CD, perpendicular AB. I can put that little symbol there. Okay, we also know that segment AC congruent to segment BC. All this is given. So if we mark AC and BC, notice that is the hypotenuse because it's across from my right angle. Okay, so we have the hypotenuse. The only thing that we really need is we need to know that they're right triangles, which we're almost there. I mean, we kind of got the symbol for it, and we need the leg. All right, so the leg is pretty easy. You can see it's right here. Here's your leg, right there. It's congruent. CD congruent to CD, and that's reflexive. But let's talk about this. So if you're perpendicular, what did we know about perpendicular? That's right, that these angles have to be right angles. So angle ADC and angle BDC are right angles. And that's because definition of perpendicular. Again, if you're perpendicular, talk to me about right angles. Well, since these two triangles have right angles in them, that means that those triangles are right triangles. Because that's what it means to be a right triangle. Right triangles only have one right angle. Are right triangles. Triangle ADC, triangle BDC are right triangles. That's just the definition of right triangles. And now we have our right triangles. We got the leg, we got the hypotenuse. Triangles have to be congruent. Triangle ADC congruent to triangle BDC because we have hypotenuse leg.